So today I have a couple of demos about the mechanical sensor. When we talk about mechanical sensor, the author was talking about the mechanical quantities. So the sensor can be electronics, a lot of those. So they are measuring pressure, measuring flow, measure the what else? So they are measuring mechanical quantities. So first demo, first I will finish last week. What we did last week is this temperature controller. It can be standalone. So last week I enabled to demo that. The reason after the lab I checked it out, it's two reasons. Reason number one is because the software need to be changed a little bit. So you have to initialize this chip to be standalone. My original code did not initialize it. So that's one single bit you have to change from 1 to 0. After you change that single bit from 1 to 0, so that's the first half. The second half is these two wires. The yellow and the blue wire need to be grounded. So it has to go to this black wire. So the black is ground. Oh, let me stop the sharing. I think the camera is too small. Now it's bigger. Okay. So this yellow and the blue wire need to go back to the black wire. So that's the ground. So I will ground those two wires. Now it's standalone. So right now it's too cold. The heater is turned on. So right now my heater is on. My heater is on. That's one thing. So if I continue to now it's warm enough. Both are turned off. Yeah. Now both are off. So I will keep. This turned on again. I guess it's getting cold again. So basically, it was right there between the thresholding, between turning the heater on and off. If I warm up this chip, the heater will be turned off, and then the air conditioner should be turned down. So. Still heater is still on. So okay. And now heater is turned off. So now it's getting the temperature right between the high-low threshold. And if I continue warm up my chip, 3 more degrees. I hope my finger today is really getting colder, so probably that's the reason. Because when I was working on it yesterday, it's pretty warm. But anyway, so the high-low temperature need to be changed based on the. I hope I have something hot to speed it up. But anyway, it's not the 3 degrees of increase from my finger. Now the air conditioner is turned on. So that's so this is a very good setup. So if you need to build a cat house, a dog house outside, I always want to build one, but I probably will do it sometimes for my cat. That should be a good chip. So all you need is to program it, and then this will go to the heater, this will go to the air conditioner. You cannot connect them directly. If you want to control about the 30 watts, you can do it one stage through a transistor. So you have to go through a transistor. If you want to control the air conditioner, generally air conditioner is about at least 500 watts. So if you want to control 500 watts, you need two stage. That means stage number one, you have a transistor. So this wire goes, this LED, instead of LED, you have a transistor. Today is really cold. Now the heater turned on again. So after transistor, the second stage will be something like relay. So you need a relay can handle 500 watts. So two stage in case you're interested in building something 200 watts or 500 watts. Control a 500 watt heater. In the case of a cat house, I actually bought a commercial one. It's 20 watts. 20 watts. So that little cat, 20 watts. It's not warm enough. My neighbor is coming over, said, no, it's not turned on. I said, yeah, it's on. It's 20 watts. 20 watts, not a lot of heat. So probably a good idea would be shooting for something like 100 watts, 200 watts. That's make your cat happy in the winter time. So that's the first one. The self standalone controller can control both heating and cooling. The next one will be this not this one. Let's do this. That's our next demo. This is a accelerometer. It's almost the similar thing inside your cell phone. So when you have your cell phone can measure acceleration. So if you accelerate, that's acceleration, and the braking, because I stopped it, I accelerate and stop it like this. Acceleration is measured by this chip. It's a tiny little one right in the center. This is based on the hot vapor chamber. So basically inside they have a little dome-shaped hot vapor chamber. As long as I provide the power, this little heater inside will warm up, and the hot vapor will be on the vaporized. The material inside will vaporize. And you have a hot air because the hot vapor is lighter. So at the top of the dome, you have the highest temperature. At the four corners of the dome, you have the lower temperature. So what happens if you tilt? When I tilt, the hot vapor will go to the corners. So if I tilt that direction, go to a corner. If I tilt XY direction, it will go to the corners. There are temperature sensors, 4 of them, around the 4 corners of this little concealed chamber. And by measuring temperature, you measure the angle. So in case of your cell phone, you can play video games, for example, by tilting. Same thing here. You can tilt, and it will measure angles. This one is called two-dimensional, two-axis, not two-axis. So it measures XY. Some others can measure XY. This is X, this is X, this is Y, and this is Z. So some others can also measure Z angle. Z angle means rotate. X, Y, Z. But this one, it did not measure Z, Z axis, just XY. how do they measure acceleration? If you are a passenger inside the vehicle, you notice when the vehicle accelerates, what happens? You fall behind, right? When the vehicle brakes, you kind of shift forward. The same thing happens inside the hot vapors. So if I'm doing this, the hot vapor will be shifted back and forth. That's physics. So this sensor will measure both tilt and acceleration. So let's do a demo. In order to do a demo, first you need wires. So look at the wires, it's so simple. This dark wire, dark blue is ground. This is power and ground. What about the blue one, light blue? Light blue will be the X, yellow will be the Y. So those are the data. This will be the data, tell the computer the angle of X can be positive or negative. Positive and negative, that's Y. So that's the hardware wiring, very simple. All you need is 2 wires. One is X, one is Y. And then we need the program. The program, like I said repeatedly, runs on this computer. This is my little computer. The computer is has an operating system built in. We do not call it. Yes.
So that tiny piece has its own operating system.
Yes, correct. The operating system is very tiny. We call it a tiny operating system. We call Microsoft. No, we don't call it Microsoft. We call TinySoft. So this tiny operating system, we don't even call it TinySoft. We call it bootloader. So this little operating system is very tiny, 2,000 bytes. 2,000 bytes. Even though it's tiny, it can do one thing. It can run basic program. Anybody has a basic experience run before, like high school? You guys. So you can write a basic program, and this computer will run basic program. The program will be loaded up from my laptop. I will edit the program on my laptop. The program will load up from here. So that goes to my computer. Let's plug in. So that's the plug-in. I will plug into my computer, USB. So the green light is turned on. It says computer is connected. That green light turned on. And then I plug in this. So that's that 2 computers now wired together. Once the 2 computers wired together, I can download my code from my laptop to this chip. This is a little memory holding all the programs. So whatever I typed, my code will go through this to here. And then my operating system on this computer will read the code and execute it. Read it, execute, read it, execute. It can execute 3,000 code per second. 3,000 per second. So if your code is 30 lines, it will take how much? 30 lines will take 1 millisecond, right? 10 milliseconds. If your code is 30 lines, 10 milliseconds to finish the code. So that's the setup. So download and run the code. Of course, this computer needs a power. So that's the power. I will plug in. My laptop needs another program. So in my laptop, I have to have a program to edit my source code. So this is the program in my laptop. Let me share my program. So on my laptop, I need this program called the BS2. So this BS2 is the program. So I will I already finished the coding, so all I need is so this is the code. This is the code. I turn the power on, so my computer now has power. So I plug in the power, and I hit the run button. The run button actually should be called the download button. So download, done. Now I can tilt. That's the Y angle, so negative Y. So if I tilt on Y direction, that's negative Y. That's positive Y. So notice the maximum limit is kind of 50-some degrees. It cannot measure 90 degrees and above. Think about a little dome chamber. Obviously, if the dome is 90 degree, it's cannot measure over 90 degree. So that's Y direction, that's X direction. Positive X, negative X. And then that's both X and Y's. And then I will shake it. Shake it means acceleration. When I shaking it, I will accelerate and deaccelerate. So that's the shaking part. So if this is measure the accelerometer function. So I will measure the accelerations. So that's I actually did one more project on this chip. That is, I actually mounted this chip on the top of my golf club. My golf club, I put one of the chip using duct tape just mounted on my golf club. And when I swing, I try to measure my swing because I'm so frustrated with my golf game. So now I know why I'm so bad. I still don't know why I'm so bad, but anyway, it will measure the acceleration of your golf club. So if you try swinging your club too hard at the top, that's no good, right? Everybody play golf? So if you swing your club too hard at the beginning, you lose in steam when the club actually hitting the golf ball, and you ended up hit 20 yards. So that's our number one demo about the accelerometer, acceleration, and also angles. By the way, the hot chamber is not hot enough, not hot at all. So I'm touching the top of this chamber. It's not hot. So it's a tiny little bit of heater. It doesn't need a lot of power to vaporize the material inside the chamber. So that's our second sensor. It's an accelerometer. It's very inexpensive. So this thing is everywhere. You can put it video game consoles. Yeah, video games. That's pretty good. The last one I prepared. Last one is a ultrasound. So it will measure distance. This ultrasound sensor is used as a parking sensors. So if you park your car, generally they put 2 or 3 in the front bumper, 2 or 3 in the rear bumper. So when you park your car, this sensor will turn on. And for example, if you're getting closer to a tree or another car, they will beep. They will have audio. Generally, the audio, which is preferred. So your audio will start beeping. The closer you get, the faster it will beep, like a bum 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 bum. When it goes so close, you need to stop. So they put 2 or 3 in the rear bumper, front bumper. It works perfectly in that application. The camera also helps. Some people prefer camera, but I prefer audio because my eye is free. I don't have to stare at a monitor, a screen. I can look wherever I want to look while parking. And my ear is an extra help. So this will be a parking meter, parking help, parking sensor. This is a very simple, it's called the transceiver. So one is the transmitter, one is the receiver. The transmitter, let me close the share so you guys can have a closer look at this. So one is the transmitter, one is the receiver. The transmitter will send out a short burst of ultrasound, very short burst, like a pin, little pin. We cannot hear it. Maybe my cat, which is sleeping right by my side, maybe my cat can hear it. Yeah, I'm pretty sure he can hear it. The dogs and cats, when my neighbor's dog is barking so violently towards me every time he saw me, I have a ultrasound dog trainer. That's pretty good, working pretty good. Now he knows I'm not the one he should bark at and be successful and victory every time. Because if the dog gets victory every time, now he is so frustrated he stopped barking at me. So this is a little ultrasound transceiver. This is a receiver. Receiver will measure the time for round trip. So if you echo, if I put my hand like this, the echo will bouncing back. So the receiver will measure the time. The time will be sent over to my computer through this blue wire. So this sensor is really simple. The black is the ground, the red is the power, the blue is data. The data is basically time. So whatever bouncing back, the time the sensor measures, it will tell my computer time. And we will have identical setup. I will plug in my computer to my laptop. And now I will share my laptop. Oh, did you guys see the tilt I was demoing? The angles? I suspect you guys did not see it at all. Let me redo it. Did you guys see the angles when I do the demo?
What demo?
The demo for the angles of my tilt.
I don't think so.
Yeah, the X, Y, and Z.
That's something about Zoom. You have to in the same app of different windows. If you share one window, you switch windows, it doesn't automatically switch. It's a safety issue because last year a lot of people get into trouble because they were assuming they will share that window, but they were switching windows. They show something. Anyway, let me re-show this.
You're talking about the XYZ?
Yeah, XYZ. Yeah.
Yeah.
Yeah, let me know because I didn't really saw that. I forgot about it. I noticed that I watching the recordings myself. I noticed, hey, now you guys got it. So that's the X. That's the Y. No, the negative X. Positive X. Negative X. Negative Y. Positive Y. Now X and Y both together, I rotating from that angle. So X and Y. X and Y. Now I shake it. It will measure acceleration. All right, that's the accelerometer and the tilt angles. Let me stop the share and let me open another window. Okay, let me share that window. All right, this is the ultrasound code. The program is very simple. The program is so simple. If you look at the program, all it does is send out a pin. This code will send out a short burst of ultrasound through pin number 15. And then the second code will read the time. Wait for how the bouncing time. And then it will multiply the speed of sound. It will do calculations. One is the speed of sound in centimeters, multiply time. The other is the speed of sound in inches, multiply time. And the next two will display on the computer terminal. So it will put the distance it just calculated on my terminal. And then it will wait for 0.1 seconds, that's milliseconds, 100 milliseconds, and then repeat forever. So this sensor will measure about 10 times every second the distance.
How many times?
10, because the delay is 0.1 milliseconds. And
Okay.
those instructions will take some time. So you put it all together, maybe 0.2 seconds. So you take 0.2 seconds for one measurement, so 5 times, maybe 5 times every second. All right, now that's the measurement. So that's my hand. Right now, my hand is 2 inches away from all 7 centimeters away. Now it's 7 inches away. So in the case of parking, when you get into this close, you really need to stop. When you still have 12 inches, so that's probably okay. 6. So it's just to keep measuring the distance, ultrasound. So if I point in my wall, that's 41 inches. I'm 41 inches away from the wall.
How far can that thing?
Yeah, excellent question. I'm pointing at my door, 80 inches.
Damn.
My room is too small. Actually, it's 100 inches. So I have a tiny little room right now. So it measures all 4 corners. That's my window. It's about 10 feet. Too long, the echo is too weak. You cannot hear it. So you have to be able to hear the echo. Let me point it at my cat, which is sleeping over there. You probably can hear it. No response. Maybe I have a deaf cat, I didn't know. That is this one, ultrasound sensor. This ultrasound sensor can be used to measure, for example, liquid levels. So you can put the sensor at the top of the tank, and the water level goes up and down. So that's a full, that's an empty tank. That's a full tank, empty tank. And, I think this will be a good sensor for the gas tank because it's ultrasound. It's safe. You do not have electric sparks inside the gas tank. This ultrasound will be much safer. The electric sensors are everywhere. Electrical devices. For example, I'm wearing this phone. I got it many years ago from Sam's Club. This phone has called 3 sensors. So I got 3 sensors on my phone. So I got the temperature. I got the temperature. So that's nice, 82 degree temperature. 82.2 degree. I got the pressure, that's 975 kPa. I don't know what that means, 975 kPa. And then I got the magnetic sensors. So that's the north, the direction of north, keep changing, north. And then I got based on the air pressure, it will calculate I'm 1,000 feet tall, 1,000 feet above sea level. So this is not accurate because the air pressure kind of changes, depend on the weather. But it's accurate to a certain extent. So before the class, it's at 1100. Right now, it's 1000, 1000. So the pressure just before the class and right now dropped a little bit. What does that mean? The air pressure dropped. That means bad weather is coming, right? So probably we'll get some rain tomorrow. I don't know. So if the pressure is increasing, that means a clear, sunny day is coming. So that's the sensors demo. So that's all the demo I prepared for today. Our second, we will spend maybe 5-6 weeks on the PLD. So if you got the chance, just buy it from Amazon. So when we get started, we have all the parts and power supply
So you're saying now we need to purchase those parts we were looking at?
Yeah. So if you have got a chance to start.
I have a power cord at home from an old laptop.
Mm-hmm.
Do I need the cord before then, or will I be able to go home this weekend and grab it?
We will do it after maybe on the 9th week. This is the 7th week, so we still have 2 weeks.
Okay.
Yeah.
Can you send us a list of what we need to buy then?
Yeah.
Because I remember
my number one this weekend I will do the midterm exam. After that I will write up instructions. So on the 9th week I will have everything. But right now, yeah, it's a good idea. Maybe I will do a partial document, put the list and put it on Canvas because I'm asking you guys to buy. I will put a list of parts maybe today. Good suggestion, Craig. I will do it today.
All right, perfect.
Week, yeah. I will put it on Canvas, parts numbers, everything, the power, the type of a power supply you need. Yeah. That controller is really good. I've been keeping an eye on my controller. It works wonderful. Temperature. The only thing bad is the light bulb is I have a 40 watts light bulb. That's for 120 power. I'm using 20 watts power. 40 watts only have became 4 watts. So my heater is only 4 watts. That's only warm up about 7 degrees above room temperature. So I can control my little box. If my room temperature is 60, the box can go from anywhere 60 to 67. I can control that. So I really need a better heater, a more powerful heater. My ideal will be 20 watts. I do not recommend more than 20 because it may get too hot and you get a fire going. But 4 watts is too little. Maybe 10 or 20 would be good. So if you need 20, you need based on my calculation, you need a 100 watts light bulb. 100 watts. You need to put it in parallel. So each will provide 10 watts. Right now, I don't have any. I look anywhere around my house. The 40 watts is the only one I can find. I'm not sure. You guys maybe have a better luck. I may go to Menard, just buy one 100 watts, maybe if I needed that. But right now I don't feel I need that because, yeah, 7 degrees, 7 degrees. The reason 7 degrees is not enough. For example, if you want to build an incubator, I'm not sure how much, but the 7 degrees is not good enough. 7 degrees above room temperature is not good enough. You might need 20 degrees above room temperature for incubators. The temperature is so accurate. So if I set it to 73.6 degrees, it is 73.6 degrees. The controller also has an auto-tuning function. The auto-tuning works perfectly. I was surprised. Auto-tuning. The PID need to be tuned. People tuning those need some experience. That's the subject we're going to cover at the very last chapter, chapter 12. But this PID controller came with a self-tuning code. So when you turn the power on, you go to the self-tuning. Of course, you have to first complete the whole system, the sensors, everything, the heating element. You have to seal the small box pretty good, pretty tight. I didn't put insulations. Maybe a little bit of insulation will be even better. And then once you're done, then you start self-tuning. The self-tuning works so good. All right, that's all I have for today. I will send out the email once I finish that. And then on the weekend, I will work on the test. I will put that next week. We will talk more about tests next Monday when Matt. So the test will probably be on the Wednesdays and Thursdays or Fridays, next Friday. I will have a timed test. I haven't decided. I actually take a look at it. I can put a timer. So when you start, make sure you have like 2 hours or 1 hour. You don't have something you need to take care during that hour, because once you start the timer just stopped 1 hour. And also I may decide it's just you can, maybe not, because there's another function that means you cannot change once you choose the answer. That's not good. I think should be able to allow you guys to change your answers. But a lot of time I notice when you change answers, you just pick the wrong answer. 50%. Many times you pick. Anyway, I will put that next Wednesday maybe. Work on this if we can. So anything else before I stop recording our lecture?
I got nothing.
Thank you, Craig. How about Tim?
No, I don't have anything.
Austin, Kobe, Cooper, Cameron, Jeremy. Oh, so many people are here. I didn't notice that because
I got nothing.
I was thinking only 1 or 2 is listening to me. Yeah. I have a couple guys. Yeah. All right, I will turn off the recording and I will see you guys next Monday. We'll talk about the optical sensors, the last chapter for first exam. And also we will have demos on the optical sensors. I will have 2 or 3 demo again like today.
All right, sounds
All
good.
right.